All right, 10.3, day one, we're starting to talk about operations with radical expressions. I think they relate a lot to operations with polynomials. So let's think back when we have polynomials. You know, we can multiply them together, x to the third times xy times y to the sixth. We would multiply the x's together and we get x to the fourth, the y's together and get y to the seventh. Now with radicals, when you look at those, kind of like when you have 2x times 3x, I can do that right at 6 and x squared. I multiply the numbers together, and then I multiply the variables together. It's kind of like that where you multiply the numbers or the coefficients together, so 3 times 2. And remember, multiplication can be done in any order, so it's fine. And then I'm going to multiply my radicals together. And you get 3 times 2, which is 6. Square root of 5 times square root of 6 would be square root of 30. You should check to see if square root of 30 can be simplified, but I know it can't because this would have been 5 times 3 times 2 if I broke that 6 up, and you'll see there's no pairs that I could pull out. So the answer is 6 square root 30 when we simplify. All right, combining like terms. Remember back in the day, can we combine these? X squared and x to the third? And hopefully you should have said no because they're not like terms. You need the exponent to be the same. So you need the base the same and the exponent to be the same. We're just collecting or gathering how many x to the seconds we have or how many x to the thirds we have. How about this? Square root of 3 plus square root of 5. What do you think? And hopefully you said no because these are not like radicals. So what's under the radical has to be exactly the same for you to combine like terms. So like or not like, put me on pause and tell me what you think if these are like or not like. So we put a tricky one in there, but hopefully you'll look at the first one and realize that they are like because what's under the radical is exactly the same. The second one, not like, because there's an x in the under the radical in the first one and there isn't in the second. The third one, again, they're like terms. And the last one's a tricky one. So we have to take a closer look at it because we can simplify 8x. It breaks up to be 4 times 2x, and then 4 breaks down into 2 times 2. So we can have a pair of 2's under, we pull 1 out, and you get 2 square root of 2x. So now 2 square root of 2x and 4 times the square root of 2x are like terms. So that was a tricky one. So when we have polynomials, so if you have 2x squared plus 3x squared, remember that. Hopefully, put me on pause and tell me what that equals. And hopefully you said 5x squared. Remember, we're just gathering like terms. We're gathering x squareds. How many do we have? Altogether, we have 5. So same thing here. It's just like that. We're gathering like terms. How many square roots of 11 do we have? We have 6, and then somebody gave me 9 more. 9 and 6 is 15. So the radical part in addition and subtraction doesn't change. It stays the same. We're just gathering like terms. So we have 6 square root 11 plus 9 square root 11 equal 15 square root 11. All right, simplify. So this would be 1 square root of 3 minus 5 square root of 3. Put me on pause. Hopefully you said this is negative 4 square roots of 3. Again, this square root part doesn't change. We're just gathering how many we have. You had 1, somebody took 5 from you, so you're 4 in the hole. So negative 4 square roots of 3. All right, put me on pause again. You give us a try. All right, hopefully you said 7 square roots of 2 minus 8 square roots of 2 is minus 1 or negative 1 square roots of 2. Or just negative square roots of 2. 5 square roots of 5 plus 2 square roots of 5. 5 plus 2 is 7, so we have 7 square roots of 5. Radicals always have to be reduced. If you can reduce them, same with fractions, you know, we can't leave 2/4 as an answer. We have to reduce it to 1/2. So let's look and see, can we subtract these as they are? No, because our radicals aren't the same. So we have 5 square root 3 minus, I'm going to break this up, And I want a square root of 3 in there, obviously, because I want them to be the same. So I think what goes into, how many times does 3 go into 12? So I know that breaks up into a 3 times 4, but I'm going to break my 4 down right away as 2 times 2. So 3 times 2, 6 times 2 is 12. So that would be my 12 broken up into prime factors. And again, we have 2 in, so hopefully you remember only 1 comes out. So this would be 2 square roots of 3. And we had that 5 square roots of 3 minus 2 square roots of 3. So now 5 minus 2, 3 square roots of 3. All right, let's do another one. So 4 square roots of 7, that's already reduced as much as it can be. Square root of 7 is a prime number. Remember, only 1 and 7 go into it. 2 square roots of 28. Don't forget to keep that 2 out there. Let's break my 28 up. I know I want a 7 in there, so 7 goes into 28 4 times. So there's my 7. Again, I'm going to break my 4 up into 2 times 2. I have a pair of 2's. So I already have this 2 right here. And a pair of 2's times is multiplication. Some people all of a sudden switch it to addition, but it's not, even though you get the same answer there, because 2 plus 2 is the same as 2 times 2. It's multiplication. And what's left in there? 7. So I have 4 square roots of 7 plus 4 square roots of 7. And that equals, oh, that's a crazy 8. 8 square roots of 7. All right, put me on pause. You guys give this one a try. You're going to have to reduce both of the numbers, obviously, and try to get a match. All right, here's how I did it. You guys can use a tree if you want. I just always break them up under radical because I lose them in a tree. But I broke my 32 up into 8 times 4. And then I'm just going to go with the 32 here. So I have 5 times the square root of 4 times 8. Then I broke my 4 up into 2 times 2. And my 8 up into 2 times 2 times 2. Which would be then I could take 2 2's out. So I have 5 times 2 times 2. And the square root of 2 left, which is 20 square roots of 2. So that's that side. Then the other side, I broke my 18 up into 9 times 2. So I have square root of 4 square root of 9 times 2. 9 is 3 times 3 times the 2 that we started with. So I end up taking out a 3. So 4 times 3 is 12. So I get 20 square roots of 2 minus 12 square roots of 2, which is 8 square roots of 2. All right, back to polynomials. If I do this multiplication, distribution, which is multiplication, I take 2 times 2x times x. The 2 doesn't multiply times anything because there's not a number, or actually it multiplies by this number 1. But x times x is x squared. So numbers times numbers, variables times variables, right? So here I take my 2 times my 5. I don't have anything to multiply that x by, so it just stays in x. So I would get 2x squared plus 10x. Same idea with radicals. So I say numbers times numbers, radicals times radicals. So if I take square root of 2, it has the square root of 6 to multiply together. So I have square root of 12 plus, now this is just 1 square root of 2. So I take 1 times 5, which is just 5. Square root of 2.
again, this is number times number, so 1 times 3, so it would just be 3 squared of 10. Square root of 60, does that break down? Let's think about what it was. It was square root of 10 times square root of 6, right? So you could have written it like that. Square root of 10 is square root of 5 times 2, and 6 would be 2 times 3. So you can see that we have a pair of 2's in there. So we would have 2 and 1 comes out, so 2. The 5 and 3 can't do anything with, so put back together. Square root of 16 plus 3 square root of 10. Alright, you try this one, put me on hold. When you're done, turn it back on. Alright, for example, we do square root of 5 times square root of 10, which would be square root, I'm just going to leave it like this, times 5 times 10 to begin with. We can put it together and make it square root of 50, but then I think we're going to have to break it up. So, I'm going to leave it as 5 times 10. And then minus 3 square root of 5. Let's see about this 5 and 10. I know 5 can't do anything with, but 10 is 5 times 2. So, again, we would pair 5's in. 1 comes out, so 5. I still have square root of 2. Minus 3 square root of 5. That 3 square root of 5 and the 5 square root of 2 don't combine it anyway. They're not in terms, so that would be my answer. Alright, so here we're going to simplify. We're going to FOIL this. So we can do it with the box. Remember the box method? Where we would put like square root of 6, negative 2, square root of 3 on one side from this. And then we have 4 square roots of 3 and 3 square roots of 6. And then we multiply, this will be this, and that goes in that box. So negative 2 times 4, which is negative 8. Square root of 3 times square root of 3 is 3. So in this box is negative 24. Negative 8 times 3. The top box, top left, I have 4 times 4 square root of 3 times square root of 6. So that would be 4 times 1, which is 4. Square root of 3 times square root of 6. Square root of, let's think of this 6 as 3 times 2. That would be 3 times 2 times my square root of 3 from the 4 square root of 3. And this simplifies to be 4. I'm going to pull a 3 out. So 4 times 2, which is 12. Square root of 2. Top right, I have 3 square root of 6 times 1 square root of 6. And that would be 3 times square root of 6 times square root of 6 is just the number 6. So we're doing 6, which is 18. And then last but not least, we have negative 2 square root of 3 times 3 square root of 6. Negative 2 times 3, negative 6. Square root of 3 times the square root of 6. This is right again, the square root of 3. I'm going to break my 6 up into 3 times 2. So that's square root of 3 times square root of 6. I have a pair of 3's inside, so 1 will come out. So I have negative 6 times 3, and then square root of 2, which is negative 18 square root of 2. Now we have to combine our like terms. So if you look this way, I have just some numbers. I have 18 minus 24. And then if we look the other way, we have that answer and that answer, which would be plus 12 square root of 2 minus 18 square root of 2. So 18 minus 24 is negative 6. And then these have the same radical, so I'm just going to put the coefficients. 12 minus 18 would be negative 6 square root of 2. So that would be my answer. That's it. Actually, let's try one more of those. So I'm going to do another one similar to this. So square roots of 3 minus 3 square root of 2 times square root of 5 plus 3 square root of 3. All right. If we do it the FOIL method, I would just take that times that. So 2 square root of 3 times the square root of 5 would be 2 square root of 15. 5 and 3. And then next one, I will do this, and I get 2 square roots of 3 times 3 square roots of 3, so that would be plus 6. Square root of 3 times square root of 3 is the number 3, so that's my second term. And the third term, FOI, so I inside, negative 3 square root of 2 times square root of 5 is a negative 50. Negative 3 square root of 2 times square root of 5. So there's only the 3 coefficient. Square root of 2 times square root of 5, square root of 10. And then lastly, I have negative 3 square root of 2 times 3 square root of 3. So it'd be minus 9 square root of 6. This one, since I just made it up in my head, doesn't have much for combining. But, so 2 square root of 15, I can simplify. 2 times 3 is 18, minus 3 square root of 10, I can't simplify square root of 10, minus 9 square root of 6. So I don't have anything to combine here, but it's good practice to FOIL numbers out or use box method, but remember, have to multiply